You can see that the frequency scaler, I set up a socket for it. You get your AC in right here. Tie it into a Variat. Set at 110. We got a 1200 1.2K resistor here, and I just tied in a 10 watt load, and that's in between pins 1 and 2. And over here on this side, based on the diagram, I put a 10K resistor here on your input, and that's between pins 3 and 5. You have your DC voltage in, which is going to come in through 4 and 5, and this is your DC pulse here, which I've just got hooked up to a cam switch on a drill, which is just going to pulse the DC at the frequency the drill's moving at. Your oscilloscope leads tied in between leads 4 and 5. So we're just going to plug the scaler in. Okay, and we're going to turn our AC on, which is actually already on. We have our oscilloscope hooked up over here. And go ahead, Mike. And you see we got square wave signal coming out of it. Got a tiny bit of AC ripple on top. Correctly sizing the resistor on the DC pulse could possibly eliminate that little tiny bit of AC ripple on top. Go ahead and speed it up, Mike. See, it's pretty consistently outputting the square wave. So if you have any more questions, feel free to give us a call, and we will be able to do our best to help you out. All of our information came right from the paperwork that you sent us. You have a dry contact set up, and you have an open collector output, which is right here. Shows you how to set that up, and if you read through the paperwork, it requires a 1.2K resistor for the open collector, and then between pins 4 and 5, and it just has a resistor pictured here, so I just threw a 300 ohm resistor in there. It's possible you could throw a little heavier on the load that you're putting across it. Plug and play unit, you actually do a little figuring, a little sizing to get everything to do exactly what you're trying to do with it. So bench testing it, you're going to have to use your imagination a little bit. Alright, thank you.